Right, in this video here, I'm going to have a look at co-functions, and I'm going to just start off with a little diagram that we're very familiar with. This is one of our special triangles, okay? What I just wanted to show you here, okay, we know that from this, the length of the hypotenuse is 2, my shorter side is 1, and then using Pythagoras, that's √3, okay? If I had to, for example, use the 30-degree angle, and say sine of 30, okay, sine of 30 will be 1 over 2, okay, because it's opposite over hypotenuse. Okay, then if I had to say, if I had to take this angle here, we know that that angle there, based on the some angles of triangles, that's the same as 90 minus 30, okay? The sine of this angle here is 60, which is 90 minus 30, and the sine of this angle is going to be equal to √3 over 2. Now I'm going to have a look at the causes, okay? I'm going to go the opposite way for a reason. Okay, I'm going to have a look at what happens if I have cos of my 60-degree angle. Okay, so I'm just going to wind this up a little bit so that I can see more of my page. Okay, so now if I have cos of 60, so I'm looking at this angle and I'm wanting to find cos. So it is 1 over √2. I say 1 over 2. Okay, remember this is also, I could also write this as cos 90 minus 30. Okay, they're both 1 over √2. Okay, likewise I can find sine of the 60-degree angle, and the sine of the 60-degree angle would be √3 over 2. Remember, I can also write this as sine 90 minus 30. Okay, that a point that I just wanted to make here is, can you see the value of a half and the value of a half are both the same for sine 30 and cos 60. So can you see this is sine 30 and cos 90 minus 30? So this is exactly where we're going with the co-functions, is that the co-function of 90 minus 30 is exactly the same as the sine of 30. Okay, so where we're going to go is we have a sum that says what is cos 90 minus theta. Okay, and what we have to know is that if I want to reduce it, I change the cos function to a sine function, and it just becomes sine of 30. Okay, so the cos of 90 minus theta is the same as the sine of 30. Okay, the sine of theta, and it's based on this principle here, is that if I have an angle here, the sine of this function here will be opposite over hypotenuse, and in terms of this angle here, which is 90 minus that angle, it is adjacent over hypotenuse. So it goes from being the sine of this angle to being the cos of the 90 minus angle. Okay, so that's just where it comes from. We don't really need to, that is understanding why it works. We then have reductions in all our, all the different co-function reductions. So just to show you these here. So first 90 minus theta. Again, the important thing just to know is what quadrants that puts it in. So that basically shows us that that's quadrant 1. And again, just in terms of looking at a Cartesian plane, I'm just going to crank this down a little bit so you can see it nicely. Okay. If I used my same 30-degree angle, and that's my 1, 2, √3, I've just really, what we saw just now was like that. I've just turned it on its side and put it in a Cartesian plane. Okay, our x and y coordinates. This is my x value, so my x coordinate becomes √3. Okay, this is my y value, my y coordinate becomes 1. Now, if I go to 90 minus theta, so now I've put my 30-degree angle here. So there's 90 minus my 30-degree angle. Can you now see that this now, the length of this line here, which is √3, now becomes my y value, and the length of this here, which is my 1, becomes my x value. So now my coordinates are 1 and root 3. Okay, so the 90 minus theta and the theta, just the x and the y swap around, and hence the cos becomes sine and the sine becomes cos. Okay, so as we reduce these, the simple thing to remember is whenever you have a 90 plus or minus, it is a cofunction. So we treat it in exactly the same way as we have before. We say, important to remember here, we look at our original function. There's my original function, it's sine, okay? In a cast diagram, where is 90 minus theta? 90 minus theta is in quadrant 1. Sine in quadrant 1 is positive. The function now becomes its cofunction, and we reduce it to in terms of theta. Okay, cos 90 minus theta, again 90 minus theta is in quadrant 1, so it is positive, it is a cofunction, so it becomes sine, and it's theta. Okay, so 3 things: what is its sine, what is a function, and what are we reducing it to? Okay, in all the cofunctions it changes, so it's something you've got to remember with the 90 pluses and minuses. Okay, in the next one we're dealing with 90 plus theta. Okay, just so you can see where the arrow goes. In my Cartesian plane there's 90 plus theta, so in terms of my cast diagram, remember that that puts me in quadrant 2 where only sine is positive. So in this quadrant here, I look at my original function and I say, what is sine in quadrant 2? Sine is positive, so it becomes a positive. My function changes to a cofunction and I reduce it. Okay, cos, what is the original function in quadrant 2? The original function is cos, and it is negative, and it is reduced to negative sine theta. Okay, theta minus 90, I'm just going to crank this up again so you can see my whole page. Okay, so theta minus 90, just there's theta, and I'm subtracting 90. So there's my 30 degrees, and I'm subtracting 90, so theoretically this would become negative 60. The key thing that you got to know is that puts it in quadrant 4. And then it's exactly the same process. My original function is sine. What is sine in quadrant 4? It is a negative. Because it's a 90 plus or minus, it becomes a cofunction, and we reduce it. What is cos in quadrant 4? It is positive. It's a cofunction, so it changes, and this here becomes theta. And that's all there is to it. So it's just remembering that with the 90 pluses and minuses, you need to know what quadrant it's in, go to the original function, see what sign it has in that quadrant, remember to change it to its cofunction, and then reduce it. Okay, so some of you might be asking what's happening to tan. So theoretically tan and cotan do the same thing, but we don't deal with that, so you don't have to worry about that. Okay, so I'm just going to do 1 or 2 examples just so that we can put this baby to rest. I'm going to just get my board. I have some very strong handy Andy on this cloth, so I'm just going to rub that out quickly and just clean it off, and I'm going to rewrite this function so we can try this. So while I'm busy rewriting it, you guys can write yours and try it in your example book. Okay, so I'm just going to wind this down a little bit so you can, oops, that's the wrong way. You can see my whole page. That's not right. So that's sine 180 minus theta. These get quite long. Very long. Okay, all right. So I'm just going to break it up into its pieces. Let's crank this up a little bit more so we can see everything. Okay, right. So what I'll need to have, let's just put one over here, is my cast diagram. That's really all that this boils down to in the end. And I'm going to start with the first one. So I have sine 180 minus theta. 180 minus theta puts it in this quadrant. I'm going to use brackets. Sine in this quadrant is positive. You don't have to put that, but I'm just overemphasizing it, and that becomes theta. Okay, then I go to cos 90 plus theta. I know that 90 plus is here, so the first thing I need to know is my sign is a negative. It's a 90, so we use its cofunction and we reduce it. Okay. Remember, that's a negative. It's different to multiplying by negative. This is a different part of it now. Okay, so now we have sine 90 plus theta. So we say, what is 90 plus 90 minus theta? Sorry, that puts it in quadrant 1. So it's going to be positive. Sine becomes cos, and we reduce it to theta. And then cos 360 minus theta, that puts it in quadrant 4. Over here, and cos in quadrant 4 is positive, and that becomes cos theta. Okay, now it's just really a matter of tidying up. So I've got a positive multiplied by negative, which is a negative, and sine theta times sine theta. So that becomes sine squared theta. Then on this side here, I've got a negative, a positive, and a positive. So my sign is negative, and I have cos squared theta. I can see the makings of an identity, so I factor out the negative sign, and I've got sine squared theta plus cos squared theta, which is one of my identities. So that I can simply replace with 1, and my answer is -1. Okay, and that's how we do it. We just go one step at a time. And remember, this is one of these questions that you get a huge amount of marks, and they're not particularly difficult. You get a mark for reducing that, a mark for reducing that, a mark for reducing that, a mark for reducing that. You'll probably get a mark because you sorted out your identity, and then your final answer. So that's my child just clanking in the background. We do still have families, even though we're at home trying to teach. Okay, and this video is 12 minutes long already, so I'm going to stop there. This is the next sum. You can try that, and the answers to this are on the PowerPoint in the D6. That's another one. Just you're reducing. Remember the negative sign. Reducing. Remember this is a cofunction, so you have to change it. Okay. This is one that's got combinations. So that's they're now using this with instead of just thetas, they're using angles. So you need to just kind of make sure you know what to do there. I'll maybe explain that in the next video. Good luck, and I hope this helps.